I hope that this video is going to help most of my students and subscribers to understand the concept of completing squares. The question here is, find the area of the small red square which would be added to complete the square. Then write an expression to represent the area of large square. So the idea is that imagine that this particular square which I shaded red is not there. That means what we have is a perfect square with area of x square and two rectangles with area of 5x each. If that is the figure given to you, that is to say that we are beginning to work with these squares. One square like this, right? So we have one square whose area is x square, right? So this is the area x square we're talking about. And then we have two rectangles, one on either side of this square, right? So one here, the other one is here. Think that you're given a figure kind of like this. And I will write some, let me write value ax here, right? And ax in general here. Now to complete this square, what do I need? I need to fill up this square, right? So this much. So I need to find the area of that square which will complete this whole square. That is the concept. What is going to be that area, right? So that is the question for you. You can pause the video, answer the question, and then look into my suggestion. Now here is something more to it which will help you to answer the question correctly. If you take this general square, then sides of the square will be x and x. The rectangle area is ax, that means this side should be a. Here also rectangle area is ax, so that side should be a. That gives you a big square with dimensions of x plus a on each side, right? And therefore an area of x plus a whole square. Correct? So we get a binomial square. That is the concept. Now in all this, what is the area of this red square? Can you tell me that? This is what we are asking for. As you can see, dimensions are a and a on either side. That means this is a, this is a. Area should be a square, right? So that is how you can solve the question. Let us apply this concept and answer these questions. So what we have here is a big square. I should say the big square is this one. Within that we have a small square, two rectangles, and a very small square. When we say find the area of small red square which would be added, means that we have a situation where it is not there, right? What is the area of this square? This is what we need to find. So looking into what we just learned, we can say that the dimension of this big square should be x, and x is for the x square. 5x means this is 5, right? And this is also 5. Now big square is x plus 5 on either side, right? This is also x plus 5. Since that much is x and this is 5, right? If the dimensions of the squares are 5 by 5, then the area should be 5 times 5, that is 25, correct? That is how you get the area. So we got the area of the red square, and now the second part of the question is, then write an expression to represent the area of larger square. So larger means this. So since the sides of the larger square are x plus 5, area should be equal to, let me write here, of the big square should be x plus 5 whole square. I think you got the idea, right? Apply the same strategy and answer these three questions, right?